Welcome to the Slop Temple. We pray this video helps.
You start by collecting a steady light source, a transparent sample, protractor, ruler, and paper. Place the sample on the paper and draw the normal at the contact point. This gives you a repeatable reference. Once aligned, shine the laser so the central ray crosses the interface. Mark incoming and outgoing rays. Make at least 3 different incident angles and label their I and R values. This immediate hands-on setup gets you measurable data quickly, so calculations will be meaningful. You now apply Snell's law step by step, treating air as n equals 1, compute sin of each incident angle and corresponding refracted angle. For every pair, divide sin, I by sin, R to get a sample refractive index. Once done, average all values to reduce random error. If values scatter, weight against obvious outliers. Make sure to use the same units and double-check angle labels. Mixing up I and R is a common mistake. This method explains why angles rather than distance. You finish by computing the mean refractive index and estimating uncertainty from spread and instrument precision. Record the value with units and a brief error note. This shows reliability. If results deviate, inspect alignment and surface quality, then remeasure at smaller incident angles where refraction is clearer. Make sure to rule out parallax when reading marks. If you still get inconsistent N, swap the sample or laser. Persistent errors usually come from setup, not theory.
Thanks for watching. Consider subscribing if we helped you.